Hello, my dear students. Welcome back to your favorite and India's most affordable learning platform, Physics Wallah. So, in the last session of units and measurements, so we discussed about the error analysis and significant figures. So, which is a very easy topic. So, in today's session, so that's the last topic of units and dimensions. So, where we are going to discuss the Vernier calipers and screw gauge. So, these are the two devices which are used to measure the length, right? So which is a very easy topic and the questions can be expected in your competitive examinations. Okay, so for the next 1 hour or 1.5 hours, just be with me. So avoid all the disturbances around you guys and start preparing the notes. And one more important thing, at the end of the class, so prepare your own short notes. So that's very important. Okay, chalo. So without wasting much time, so let's get into the topic. So first let's understand the Vernier calipers. So the Vernier calipers, so it consists of two scales, scales. One is called the main scale. Just see the diagram once. So one is a main scale. See here. So this part 0 to 10 is there, na? So this is called the main scale. So whereas this is a movable one, which is called the Vernier scale. So the main scale, which we denote it as MS, and then so the Vernier scale, so which is a movable one, so which is VS. This one is movable, this one. So here two jaws will be there. This is jaw A and then this is jaw B. So where jaw B is a movable one, so which can be slided on this. Okay, whereas jaw A is fixed. So this is a main scale from 0 to, so some 10 are there. So and then this is a Vernier calipers. So Vernier scale. So the main scale will have the readings as well as the Vernier scale also will have the readings. So this part is clear. So first, sir, what is the purpose of this Vernier calipers? So it is used to measure the length or diameter. So it is used to measure the length or diameter. So here in the main scale, so there will be number of divisions. So the MSD, so which we call it as, so the main scale divisions. So MSD is, so the main scale divisions. So not Mahendra Singh Dhoni, so it's a main scale divisions. Clear? So these main scale divisions can be in millimeter or it can be centimeters. So or they can mention some other values. So for example, on the main scale, if I take from this 5 to 6, so 5 is here and then 6 is here, let's suppose, and in between there are some divisions, right? So 1 2 3 4 5 6 7 8 9. So 1 2 3 4 5 6 7 8 9. So and then 10. So these are the number of divisions. So let's suppose if it is 5 centimeters and 6 centimeters. So then how many divisions are there between 5 centimeters and 6 centimeters? So there are 10 divisions. So 10 divisions means 1 centimeter by 10, right? So this is 1 centimeter is divided into 10 parts. So which is nothing but 1 centimeter by 10. So which is nothing but we can write 0.1 centimeter or 1 mm. 1 mm. Clear? So this is a number of divisions. So this is how the main scale will be divided. So this need not to be centimeters always. So in sometimes in some questions they might give some other, right? So this can be varied. So but most of the times they mention it in centimeters and the number of divisions will be in mm itself. Clear? So what is main scale and what is the Vernier scale? And whereas the Vernier scale is movable or it can be slided over the main scale and this jaw is fixed, and whatever the object that you have to measure. So for example, if you have to measure, so the diameter of the sphere, so this diameter is nothing but the length, right? So the length of the sphere is the diameter. So to measure the diameter, so what we do is, so we just, this end is fixed, A is fixed, so where we keep the sphere here and then we'll bring this Vernier scale so to this side and we'll fix it up. Okay, so then we'll see the reading. How to measure the reading, we'll see in today's session itself. So this part is clear, and this is there na here. So this is used to measure depth. It measures depth. Clear? This measures the depth. So understood? So that means the vernier calipers is used to measure length or diameter, or it is also used to measure the depth. So this is a basic information based on the diagram. So let's move further. So it consists of a main scale over which a vernier scale can slide along the length. So that's what I said previously. So it will slide over the main scale. So this already we discussed. So then, so generally the divisions of the vernier scale are smaller in size than the divisions in the main scale. So here, so let me write it here. For example, so if I take the number of divisions 5 centimeters to 6 centimeters, so we have, there are 10 divisions, right? So this is 5, this is 6. So in between 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means there are total 10 divisions. So if it is on the main scale, this is a main scale division. Whereas the vernier scale will have, so the vernier scale will have more number of divisions for the same length. So this will have the more number of divisions. This is a vernier scale divisions. So let's suppose if there are n divisions on main scale, so if there are n divisions on main scale, so which will be equals to, so it will be some n plus something, so that n plus divisions. So this n plus can be anything, so n plus 1 or n plus 2, n plus 3, so but greater than the n divisions will be there on the vernier scale. So n plus divisions on vernier scale. So in place of this dash, it can be anything. So let's suppose here 10 divisions are there, here it can be 11 or 12. So if there are 12 divisions here, so it can be 15 here. So that depends. Okay, so they'll mention it in the question. So that point is clear. This one, chalo. Next. So next, or else you can write. So the main scale divisions are always number of divisions on the main scale. Write it like this. So the number of divisions on main scale will be greater than, so the number of divisions on vernier scale. Clear? Chalo. Next. So suppose the divisions on the main scale is A and that on the vernier scale is B. So for example, so this is a main scale. So let's suppose there are some A number of divisions are there on the main scale, and so this is a main scale. So and then let's suppose, so this is a vernier scale. So on the vernier scale, let's suppose there are B number of divisions. That's what they said. So the divisions on the main scale is A and that on the vernier scale is B. So then what is the smallest measurement you can make? So the smallest measurement is, so the smallest measurement of the vernier calipers, that we call it as least count. So what is that? Least count. So which is nothing but the number of divisions on the main scale, or else 1 MSD minus 1 VSD. So which is nothing but here, according to this, A minus B. So if the division on the main scale is A, one division on the main scale is A, and that on the vernier scale is B, so then, so the number of divisions, the least measurement that you can make is a C. So that C, least count, is equals to A minus B. So from here we can write the formula for least count as, so 1 MSD. So A is nothing but 1 division on the main scale, so where B is nothing but 1 division on the vernier scale. So therefore the least count formula that we can write, so the smallest measurement, which is the least count of a vernier calipers, is C, which is 1 main scale division minus 1 vernier scale division. So I'll write here, so the least count is equals to 1 MSD minus 1 VSD. So where MSD is the main scale division and VSD is the vernier scale division. So this point is clear. Chalo. So now suppose n VSD coincides with m VSD. So this means the lengths are equal. So which is nothing but, so the number of n VSD, n times VSD is equals to, so m times MSD, m times MSD. So then you can find the, so VSD will be equals to, so m by n, send this n to that side, so into MSD. So here you can always say that the n will be greater than m, because the number of divisions on the Vernier scale will be always greater than the number of divisions on the main scale, right? So that's why n will be greater than m. So here I can also write n will be greater than m. Clear? Understood this part? So chalo, so let's move further. So here sometimes one MSD has to be calculated, so they will not give it in the question. So for example, so if 5 centimeters is here and then 6 centimeters is here. So let's suppose there are 10 divisions on this, 5, 6, 7, 8, 9. So there are 10 divisions on this. So then 1 MSD is divided into, so 1 MSD is nothing but how much? See here, I can write, so 1 centimeter is divided into 10 divisions. That's nothing but 1 MSD. What is 1 MSD? 1 MSD is nothing but 1 main scale division. This is 1 main scale division, or else this is 1 main scale division, this is 1 main scale division, this is 1 main scale division. So here 1 centimeter is divided into 10 parts, 10 divisions. So that's why this is 0.1 centimeter or 1 mm. This is a 1 MSD. So 1 MSD is the smallest division on the main scale. This is the smallest division on the main scale. Let's suppose main scale has 10 divisions in 1 centimeter. See here 5 to 6 means 1 centimeter. So 1 centimeter has 10 divisions. So then 1 MSD will be equals to 1 centimeter is divided into 10 divisions. So that's why 1 centimeter by 10, which is nothing but 0.1 centimeters. Clear? Understood guys? Chal. Let's move further. So let's do one simple question. So pause the video and try it on your own. So what's the question says here? A Vernier calipers has 1 mm marks on the main scale. So 1 mm marks on the main scale. So what does that mean? 1 mm marks. So that means, so 1 MSD is equals to 1 mm. This is the first information that they gave. So it has 20 equal divisions on the Vernier scale, which match with 16 main scale divisions. So see here 20 equal divisions on the Vernier calipers. So that means 20 VSD is equals to, so 16 MSD. So as we discussed earlier, always main scale divisions will be equals to, so some greater Vernier scale divisions. So the divisions on the main scale will be less than the Vernier scale, or else so the Vernier scale divisions will be more than the main scale division. Right? So from here, so what they are asking for this Vernier calipers, least count. So first, what is the least count formula? The least count is 1 MSD minus 1 VSD. That's it. So here 1 MSD we know 1 mm, right? So then how do you find 1 VSD? So we know 20 VSD. So 20 VSD means from here 1 VSD is equals to 16 by 20 MSD. 16 by 20 MSD. So from here 1 VSD is equals to, so this is 4 4s are 4 5s are, so 4 by 5 times, so what is 1 MSD? 1 mm. So this is 1 mm. So from here, so this is going to be 0.8, right? So this is going to be 0.8 into 1, so which is nothing but 0.8 mm. So this is 1 VSD. So now find the value. So 1 MSD is 1 mm minus, so this is 0.8 mm, 1 VSD. So which is nothing but 0.2 mm is a 0.2 mm. So option D is the correct one. Clear guys? Understood the concept? Chal. So let's move further. So let's take one more question. So what's the question says here? So just try along with me. The n divisions on the main scale of the Vernier calipers coincide with the n plus 1 divisions on the Vernier calipers. So n divisions, n MSD divisions, right, like this. So n MSD is equals to n plus 1 VSD. N plus 1, so Vernier scale divisions, right? So then, so if each division on the main scale is of 8 units, see here. So if each division on the main scale is of A units, So that means 1 MSD is given. So what is 1 MSD? A units that they gave. So find the least count. So just write it here. So the least count formula we already know. What's the least count? So the least count is equals to 1 MSD minus 1 VSD. That's it. So we have to find, so what is VSD, right? So then here I can write, so N times, so what is MSD? So 1 MSD is nothing, or else. So I can write, so the VSD is equals to, from here I am writing, so which is N by N plus 1, N by N plus 1 MSD. N by N plus 1 MSD. So from here, the VSD, the Vernier scale division, is equals to N by N plus 1. So what is 1 MSD? 1 MSD is equals to A, right? So each division on the main scale is A, means that's MSD only. So from here we got VSD, and we got, this is MSD, and then this is VSD. So now we can get the least count easily. So what's the formula? 1 MSD minus 1 VSD. So what is MSD? A minus, so this part is N by N plus 1 times A, right? So from here, so if you calculate here, A is the LCM, so 1 by 1 minus 1 by N plus 1. So then here A into, so N plus 1 is the LCM, so then here it is N plus 1 minus N. So then N cancel, so it's going to be A by N plus 1, right? So this is a least count for this. Clear? Understand the procedure, guys? Clear? Chalo. So let's move further. So let's go for the next question, the question number 3. So the main scale of a Vernier calipers has n division per second. So what does that mean? N division per centimeter. So that means 1 MSD is equals to n division per centimeter. So n by centimeter, n divisions per centimeter. So what does that mean? Let's suppose this is 5, this is 5 centimeters, this is 6 centimeters. Okay. So now 5 to 6, there are n divisions. So that means what is the one division? So one division is nothing but, so there are n divisions, right? So one division is nothing but, so 1 centimeter by n, sorry, 1 centimeter is divided into, so 1 centimeter by, there are n divisions. So which is nothing but 1 by n centimeter, shall I write? 1 centimeter is divided into n divisions. Clear? Understanding? So previously, so we wrote 1 centimeter is divided into 10 divisions. So that's why 1 MSD will be 1 centimeter by 10. So similarly in this question also, so just understand here. So in this question also, the 1 centimeter is divided into n divisions. So then what will be the MSD? So the MSD will be 1 centimeter by n. So which is nothing but 1 by n centimeters. So this point is clear, right? So now n divisions of the Vernier scale coincide with n minus 1 divisions of the main scale. So n divisions of the Vernier scale coincides with n minus 1 divisions of the main scale, right? So this point is also clear. So now from here we have to find the least count. So just write the formula here. So we know the least count formula, the least count is equals to 1 MSD minus 1 VSD. 1 MSD minus 1 VSD. So where 1 MSD we know, but 1 VSD we don't know. So let's find what is 1 VSD. So from here VSD is equals to n minus 1 by n into, so what is 1 MSD? In place of 1 MSD I am writing 1 by n centimeters. So from here we can get, so VSD, 1 VSD is equals to n minus 1 by n square centimeter, n minus 1 by n square centimeter. VSD also we got. So now 1 MSD is 1 by n centimeters minus 1 VSD is n minus 1 by n square, right? So therefore if you take the LCM, n square will be the LCM, so here it goes n times, so then here it will be n minus, so here it is n minus, so minus of this one minus n plus 1, so then n cancel, so 1 by n square. So this is the least count. So the least count will be 1 by n square. Correct option will be the option D. Clear? Understood? Simple questions. Chalo. So now how do you calculate the reading on the Vernier calipers? Let's suppose, so I gave you the sphere. Okay. So I asked you to find what is the diameter of this sphere. So what do you do? So you place the sphere in between jaw A and jaw B of the vernier calipers, right? So in between the jaw A and jaw B of the vernier calipers, and you tighten this, right? So then how do you take the measurements? So the purpose of vernier calipers is to get the accurate value, right? So what's the main purpose? To get the precise value or accurate value, right? So previously we already, like, if I give you the sphere, you can just calculate it with the scale also, but that's not the precise value. So using the vernier scale we get the precise value. So how do we read this value on the scale now? So you tighten this, and how do you read this value? So that's called the reading on the vernier calipers. So where is that? Yes, see here. So this is a reading on the vernier calipers. So if we have to measure a length AB, so the end A coincides with 0 of the main scale. So the end A coincides with the 0 of the main scale. So we place the sphere here. So then the end 0, see here, this end, so it coincides with the 0 of the vernier scale, and then this one, it coincides with some main scale division, some vernier scale division. So now how do you read that vernier scale division and main scale division? That's important. Okay, so let's go for that. Okay, so let's suppose, so the end B lies between 1 centimeter and 1.1 centimeter on the main scale. So then AB length will be between 1 centimeter and 1.1 centimeters. So I'm talking about this one. So let's suppose you fixed it. Okay, so and then this length came out to be, so this one, after tighten this, so this was between 1, 1.1, 1.2, 1.3, 1.4. So it's between 1.4 and 1.5. So that means your value lies between 1.4 and 1.5. So this is fine. But next, so we should check the vernier scale division as well. So how do you check the vernier scale division? That's also very important to get the accurate value. So main scale division, fine. Chalo. So see here. So now, how do you get the observed reading? So the observed reading is nothing but main scale reading, MSR, plus the vernier scale reading. So main scale reading plus vernier scale reading. So how do you get the vernier scale reading? Main scale reading is nothing but, so reading on main scale just before the 0 of vernier scale. So just before the 0 of vernier scale. So I'll write the diagram so that you'll understand better. For example, so this is a main scale. So on the main scale, so it's somewhere around 1, 2, 3, 4, 5, 6, 7, 8, 9, so 10. So some number of divisions are there. So on the main scale, so it's showing, let's suppose here is a vernier scale. Let me draw the vernier as well. Okay, na? So this is the vernier main scale, this is the vernier scale, main scale and then vernier scale. So then on the vernier scale also the divisions will be there. So like this. So like this, the vernier scale divisions are also there. Let's suppose after tightening, so we got this is somewhere around some 5 centimeters and this is some 6 centimeters. Okay, na? So after tightening, the main scale is just, so like this, 5 centimeters here, 6 centimeters here. So then how do you read the, how do you get the final reading? So it's main scale reading plus vernier scale reading. On the main scale, what we should take? On the main scale, this is 5. So this is 5.1, 5.2, 5.3, 5.4. So this is a vernier scales 0. This is a vernier scale 0. So before vernier scales 0, so whatever the reading is there on the main scale, so that is called MSR. So that means, so this is 5.1, 5.2, 5.3, 5.4. So the main scale reading here you should take it as 5.4 centimeters, right? Plus, so then how do you take the vernier scale reading? So vernier scale reading is nothing but, so the least count into, so the coinciding division of vernier scale. So which division of vernier scale is coinciding with the main scale division? See here. So the vernier scale division, this is the first one, second, third, fourth, fifth, sixth, seventh. See here, this one and this one are exactly coinciding. So I can say seventh one is coinciding. Let's suppose this vernier scale has, vernier calipers has some 0.01 centimeters has a least count. that I am considering, just I am assuming. So into 7. So this is a procedure to calculate the reading. Understood the procedure, guys? So just we have to read what is main scale reading. Main scale reading is nothing but, so wherever the reading on the main scale just ahead of the Vernier scales 0. Vernier scales 0, before Vernier scale 0. So whatever the digit is there on the main scale, so that's a MSR. So and then what is the Vernier scale reading? So least count will calculate for that Vernier calipers into, so which division of Vernier scale is coinciding with the main scale. So that's a coinciding division of Vernier scale. Okay, chalo. So let's do one question so that you will understand better. So see the question here. So what's the question says? In a Vernier calipers, 10 VSD is equals to 1 MSD. So this is the hint given. So 10 VSD is equals to 9 MSD. Always the VSD divisions will be more if you observe, right? And then, so and 1 centimeter on the main scale is divided into 10 parts. So 1 centimeter is divided into 10 parts. So then what is a 1 MSD? 1 MSD is nothing but 1 by 10 centimeters. 1 centimeter is divided into 10 parts. So which is nothing but 0.1 centimeters, right? So then what they said, so 10 parts of measuring, while the length of the line of the 0 is just ahead of the 1 centimeter mark, and fourth division of the Vernier calipers coincides with the main scale. So the length of the line is, see here. So first we got the main scale division, we have to find the total reading. So the observed reading we have to find. So how do we get that? We know the MSD. So can we calculate what is VSD? So 1 VSD is equals to, so 9 by 10, send this 10 to this side, 9 by 10 times the MSD. So from here, so 9 by 10 into, so what is MSD? So MSD is 0.1. So which is nothing but, so this is, so 0.9 into 0.1. So which is 0.09 centimeters. So this is a 1 VSD. So now can we calculate what is least count from here? Can we calculate what is least count? So the least count is equals to, so the 1 MSD minus 1 VSD. 1 MSD minus 1 VSD. So which is nothing but 1 MSD is 0.1 centimeters minus this is 0.09 centimeters. So from here, so we get this comes out to be 0.01 centimeters. Yes or no? So this comes out to be somewhere around 0.01 centimeters. Right? Correct only, right? Yes. So then, just a minute, guys. Let me have some water. So done 0.01 centimeters. Now, so let's find the observed reading. They are asking us to find what is the observed reading. So then the observed reading will be equals to, so the MSR plus the Vernier scale reading. So the MSR, what they mentioned it in the question, see here. So divided into 10 parts, while measuring the length of a line, the 0 of the Vernier scale is just ahead of 1.8 centimeters. 0 of the Vernier scale is just 1.8 centimeters ahead. So which is nothing but, so 1.8 centimeters is the MSR that they gave. So plus, so what is the VSR that you can calculate? Least count into, so the the coinciding division of the Vernier scale. Coinciding division of Vernier scale. Coinciding division of Vernier scale. So this is 1.8 centimeters. So this is fine. So what is the least count that we got? 0.01. 0.01. So into, so what is the coinciding division of Vernier scale? So see here. So the fourth division of the Vernier scale coincides with the main scale. So fourth division of the Vernier scale. So which is nothing but 1.8 centimeters plus 0.04. Right. So which comes out to be, so 1.84 centimeters. So 1.84 centimeters. So the accurate one is this one, 1.840. So no other is matching, right? Yes. Clear? Option B is the correct one, guys. Understood? Chal. Next. So then, so in vernier calipers, so there can be the error. So whenever there is no object placed between the two divisions, see this properly. So if there is no object placed between these two divisions, bring this vernier scale, so exactly do this one to this side completely. So if the 0 of the vernier scale coincides with the 0 of the main scale, see if there is no object here, just bring completely the vernier scale to this side, so to the left side. So if the 0 of the vernier scale exactly coincides with the 0 of the main scale, so then there is no error in that vernier calipers. So but if it is not coinciding, so then there can be possibility of the error. So not possibility, there will be an error. Okay, so based on the adjustment, so we have two types of errors. So one is called the positive 0 error and the other one is a negative 0 error. So whatever the error that is there in the vernier calipers, we call it as a 0 error. If the 0 of the vernier calipers do not coincide with that 0 of the main scale, when jaw B touches A, then the instrument is said to have 0 error. So the instrument is said to have 0 error. Okay, so 0 error is always subtracted from the total or observed reading. So the correct reading will be, the final reading will be equals to, so the total reading, what is this? Observed reading. Total reading is nothing but the observed reading minus the 0 error. So minus the 0 error. Okay na? So there are two types of 0 errors. So one is positive 0 error, the other one is a negative 0 error. So when 0 of the vernier scale is on the right of 0 of the main scale, for example, so after closing the jaws, so let's suppose this is a 0 of the main scale. So and here is some 1. So and then, so the vernier calipers, the vernier scale, so let's suppose somewhere around here. So this is a 0 of vernier scale. Let's suppose this is the 0 of the vernier scale. See here. So the 0 of the vernier scale is just ahead of the main scale 0. So that then in that case, on the right side of the 0 of the main scale before the measurement, so then this error is called the positive 0 error. This is a positive 0 error and vice versa. So if the vernier scale 0 is to the left of the main scale 0, so then we'll be having the negative 0 error. So where the negative 0 error, so we take it minus. So what is the 0 error formula? So the least count into coincide division of vernier scale before measurement. So some division of vernier scale will coincide with the main scale. So what is that coinciding number? So you just check and into least count, that gives a positive 0 error. So if you want to find the final reading, so the observed reading minus a positive 0 error. So here if you want to find the total reading, like final reading, so observed reading minus negative 0 error. Clear? So depending on the type of error, so the final reading will be changed. Clear? Understood? Sure. So next we have one more device, so which is used to measure again the length. So measures length more accurately or more precisely. It measures length more precisely. So where we can get up to 8 significant figures. In the screw gauge, we can get up to 8 significant figures value. So that's a very accurate value. Okay. So let's see the screw gauge setup. So in the screw gauge, so this is called stud. This part is called stud, which is a fixed one. And then, so here the screws will be there, or which we also call them as threads. These are just like threads. So one thread, like on a nut you can see, right? So one thread through two thread, three threads like that. So these are the threads like this. Okay. And then, so this pitch scale, this is called the pitch scale. So this pitch scale, which is like a main scale, like in vernier calipers, however the main scale works, right? So the main scale MSD, so that same thing is a pitch scale. So where this round one is there na circular scale, so this circular scale is movable. this circular scale is movable, like Vernier scale, so it's like Vernier scale. So whereas pitch scale is like the main scale. Okay, so here if you observe, so this pitch scale has a divisions, so which we call it as pitch scale divisions or MSD simply. So whereas circular scale also will have the divisions, so which we call it as circular scale divisions, circular divisions. So which we call them as CSD, circular scale divisions. Okay, understanding the terms? And then, so sometimes in place of circular scale, so they can also mention, so the thimble. So they can also mention, so the thimble has some divisions. So thimble has some divisions means they are circular scale divisions only, CSD only. Okay now. So whatever the object that you have to measure, the dimensions of the object that you have to measure the dimension object. So what we do is we just place it here. Okay. So then we tighten this. So we move this circular scale. So then we tighten this. So then we read the reading on the main scale and we read the reading on the circular scale. So then we can get the observed reading. So how do we calculate that? That's we are going to see. Just understand the general procedure. So we'll see the reading on the main scale, so which is the pitch scale, and then we'll also see the reading on the circular scale. So there main scale plus Vernier scale in the case of Vernier calipers, here pitch scale plus circular scale. So that's how we can find the reading, just general procedure. Now let's get into this, what is the least count of this screw gauge and how do we find the screw gauge reading, like final reading or observed reading or total reading. And so are there any error possibilities are there here? So if there are errors, what kind of errors will be there? So everything we'll see here. See here? Clear? Chalo. So let's go for the next one. So here we define one term, so that's called pitch. We define one term that's called pitch, like their main scale division is 1 MSD. So here it is pitch, that's it. Okay, so the pitch is nothing but it's a distance between two consecutive threads. So there are threads, right? On the screw there are threads. So the distance between two successive threads, so two consecutive threads, is called pitch. Or we can also use the definition, so the distance moved by the screw due to one complete rotation. So in one complete rotation, so how much distance the screw has moved in one complete rotation, so how much distance the screw has moved, right? So while adjusting the object, what we do, so we just move it like this, right? So then in one complete rotation, how much the distance the screw has moved, that distance is also called the pitch, right? And then R, so we can also call it as the markings on the main scale, which is like a MSD. So these three definitions are for pitch. Okay, clear? Understood, guys? Clear? Chalo, next. So now, so how do we calculate the least count of the screw gauge? So in the case of Vernier calipers, so we calculated the least count as 1 MSD minus 1 VSD. So here it's a pitch, so which is nothing but MSD. Pitch is like the MSD. So by the number of circular divisions, so it's simply like, remember, MSD by CSD. So main scale divisions by circular scale divisions. So simple trick. So there MSD minus VSD, right? Here MSD by CSD. That's it. Okay, the least count. So pitch is nothing but the number of divisions or the distance moved by the screw due to one complete rotation by number of circular divisions. That's it. Okay, so let's go further. So let's see one question so that you will get the clarity, guys. So two full turns of a circular scale of gauge cover a distance of 1 mm. So two rotations cover 1 mm. Then so one rotation covers 1 by 2 mm, I can say. One rotation covers 1 by 2 mm. Yes. So what is one complete rotation? So one complete rotation is nothing but the distance moved by the screw due to one complete rotation is nothing but the pitch. So then I can say the pitch is equals to here the given pitch is 1/2 mm. Just let it be. So then the total number of circular divisions on the scale is 50. So they gave CSD. CSD how much? 50 divisions. So then what they are asking? They are asking us to find the least count. So how do we calculate the least count? So the least count is equals to pitch by the number of circular scale divisions. Number of circular scale divisions. So pitch how much we got? So which is 1/2 mm by, so the this one 50 divisions. So which is nothing but 1 by, so this 2 comes down. So 1/100 mm. So which is nothing but 0.01 mm. 0.01 mm. Option B is the clear correct one. Understood guys? So this is about the least count of the screw gauge. Understood the procedure? Chalo. So let's move further. So now how do we calculate the reading on the screw gauge? So this is also one of the important thing. So the simple thing, so the observed reading will be, so main scale reading plus circular scale reading, that's it. There in the vernier calipers, main scale reading plus the vernier scale reading. So here circular scale reading. Okay. So where, how do you take the main scale reading? So the reading on the main scale just before the circular scale. So the reading on the main scale, see here. So once you fix the object in between these, so between the screw and stud, you fix the object that you have to measure the length. So then, so you tighten this. So then whatever the length is there, for example, so this is 1. So then this is 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9. So just before the circular scale, so 9 is there. So that means on the main scale reading, I can read it as 1.9 centimeters. Let's suppose this is in centimeters. If I say this is 1 centimeters and next one is a 2 centimeters, let's consider. So the main scale reading is, so just ahead of the circular, whatever the reading that shows on the main scale, just ahead of the circular scale. So which is a 1.9 centimeters. So in circular scale reading is nothing but least count of that screw gauge into, so the coinciding division of CS with baseline. So what does that mean? So on the circular scale, there are divisions, right? See here. So this is 1, this is 1. So and then 1.1, 1.2, 1.3, like that there are divisions. So which division is coinciding with the main scale? What is the main scale line? Baseline. This is called main scale's baseline. See here. So this is a main scale baseline. So which division of circular scale is coinciding with the main scale baseline? So that division we have to multiply with the least count. So then we'll get the CSR. Clear? Understood the concept? Chalo. Next. So let's move further. So let's take question so that you'll understand the better way. So let's first see. So circular scale has 100 divisions. So CSD, circular scale, number of CSD, number of circular scale divisions are 100 divisions. So they are asking us to calculate the diameter of the wire. So the first thing is to find the reading. So the observed reading, the formula will be, so the main scale reading, so we plus the circular scale reading. So the main scale reading plus the circular scale reading. So not D, it's a R. So main scale reading plus circular scale reading. So to calculate the main scale reading, what is the main scale reading? See here. So 0, 1, 2, 3, 4, 5. So the main scale reading, I could see it as 5 in mm. So 5 mm, right? 0.5 mm. Yes or no? So this is 0 and then here it is 5. So this is going to be 0.5 mm, right? So plus, so what is the CSR, which is nothing but least count? CSR is nothing but least count into, so which division of the main scale is, so which division of the circular scale is coinciding with the baseline, right? Least count into coinciding division of the circular scale, coinciding division of circular scale. So or else let's write like this, 0.5 plus least count into coinciding division of circular scale. Sorry guys, just a minute. Sorry. So next, so we have got, so 1 MSR, so plus CSR. So how do you calculate the least count here? So first thing is least count. Least count is pitch by number of circular divisions. Number of circular divisions. So what is the pitch here? So pitch is nothing but, so in mm, yes or no? So pitch is nothing but 1 division on the main scale. So what is 1 division on the main scale is equals to, 1 division on the main scale is equals to, this is 1 mm, this is 2 mm, this is 1 mm, this is 2 mm, this is 3 mm, this is 4 mm, this is 5 mm. Okay, so this is 0, not 0.5, this is 5 mm guys, because this is in mm, this they mentioned, right? So that's why 5 mm. So then, so 1 mm by how many divisions are there? 100 divisions. So which is nothing but 0.01 mm. 0.01 mm. So then I can write 5 plus 0.01 mm into, so which division is coinciding? See here. So here it is 30. So this is 31, 32, 33, 34. So then I could see somewhere around 34th division is coinciding with the baseline. This is the baseline of the main scale and this is the circular scale. So the 34th division is coinciding. So that's why 5 plus this is going to be 0.34 mm. So I can see that. So this is going to be 5.34 mm. So but options are given in centimeters. So I can write it as 0.534 centimeters. Option A is the correct one, right? Understood guys? Clear? Chalo. So let's move further. So the question number 7. So the thimble of a screw has 50 divisions. So that means number of CSD is given. Thimble or circular scale division same. So which is 50 divisions. So and spindle advances 1 mm when the screw is turned through 2 rotations. So 2 rotations gives rise to, the distance covered is how much? 1 mm. So then in one rotation is nothing but 1 by 2 mm. So from here, so can we calculate what is the least count? So the least count is equals to pitch. So first write what is pitch. One rotation's distance is nothing but pitch. So therefore pitch is equals to 1 by 2 mm, right? So therefore here I can calculate the least count. Least count is nothing but pitch by number of circular scale divisions. Number of circular scale divisions. So what are the number of circular scale? Pitch is 1 by 2 by, so number of circular scale divisions 50. So therefore 1 by 100 mm. So which is nothing but 0.01 mm. So this is the least count. So till here it's fine. So next let's move further. So then what they are saying, when the screw is used to measure the diameter of the wire, the reading on the sleeve is found to be 0.5. So what does it mean by reading on the sleeve? Reading on the sleeve means this part, main scale. This is called sleeve. Reading on the sleeve is given. So which is nothing but, so the main scale reading is given. So what is the main scale reading? So 0.5 mm. So then, and reading on the thimble is found 27 divisions. So it's coinciding with the 27th division. So then what is the diameter in centimeters? So therefore they are asking the observed reading. So which is nothing but, diameter is nothing but they are asking the reading. So the observed reading is equals to MSR plus CSR. So what is MSR, main scale reading? What is the main scale reading? So main scale reading 0.5 mm. So then plus CSR. CSR is nothing but least count into, so which division is coinciding? So 27th division. So then 0.5 mm plus least count is 0.01 into 27. So this comes out to be 0.5 plus 0.27. So then, so which comes out to be 0. Somewhere around 77. So 0.77. So this is in mm we got. So now if we need it in centimeters, so 0.077 centimeters, 0.077 centimeters. Option C is the correct one. Right? Understanding the procedure? Chalo, let's move further. So now, like vernier calipers, in screw gauge also will be having two types of errors. So one is positive zero error and the negative zero error. So how do you get the correct reading? The correct reading will be equals to observed reading minus the error. Okay. So here, to calculate the error, so first how to check the error is there or not? So if 0 of the circular scale does not coincide with the baseline at initial condition before starting the measurement when spindle and stud touch each other. So just first completely, so tighten this. So when this stud and spindle, this is called spindle. So the stud and spindle, so whenever they are tighten up, so then if the 0 of the circular scale, this is the 0 of the circular scale and the 0 the main scale's baseline, if they both are not aligning, so then they are said to be a error. So that error is called zero error. So then whether the circular scale's 0 is above the baseline or below the baseline, so depending on that we have two types of errors. Okay. So when the 0 of the circular scale, when the this is a circular scale, so and this is a baseline, okay. So the baseline of the main scale is above the circular scale 0. See here, baseline of the main scale is above the circular scale's 0. So then such kind of error is said to be positive zero error. If main scale 0 is above the circular scale 0, remember this, if main scale 0 is above the circular scale 0, so then there said to be a positive zero error. So what's a positive zero error formula? The least count into the coinciding division. So some division of this one coincides with the baseline. So the coinciding division of CS before measurements with the baseline. Okay na? So that's called the positive zero error. So which we take this value as positive. So exactly vice versa. So the negative zero error is nothing but, so whenever the main scale 0 is below the circular scale 0. See, this is the baseline of main scale. The baseline of main scale, so is below the circular scale's 0 value. So then this is said to be the negative zero error, which we take it as negative. So the formula is again same, least count into the coinciding division. Some division will coincide with the this value. See here 44th one coinciding. So that's why least count into 44 we do. Okay. So this should be taken as minus LC. Okay. So then we can write, so the correct reading here, the correct reading will be equals to the observed reading minus zero error. Okay. So observed reading minus zero error. This zero error should be taken with sign. So if it is a positive zero error, take it as positive. If it is a negative zero error, take it as negative. Clear? So this zero error, so take this with sign. Take this with sign convention. Understood? Chalo. So let's solve one question so that you'll two questions so that you'll understand this concept clearly. So let's take one question here. So what's the question says? So I'll just stand aside, try to do this question on your own, guys. The pitch and the number of divisions on the circular scale for a screw gauge are given. So they gave the pitch. So the pitch value is equals to 0.5 mm. And then, so number of circular scale divisions. So the number of CSD is equals to 100. So these two, if you know, so can we directly find the least count? The first thing is least count. So least count is pitch by number of CSD, number of circular scale divisions. So which is nothing but 0.5 by 100. So which is 0.005. This is in mm. So that's why. So the least count is 0.005 mm. So till here it's clear. Chalo. Next. So when the screw gauge is fully tightened without any object, so the screw and stud are met. Okay, now there is no object placed between the screw and stud. So without any object, it's tightened. So the 0 of the circular scale lies 3 divisions below the main scale. The 0, that means the main scale is above, and then circular scale is below, right? So the 0 of its circular scale lies below 3 divisions below the mean line. So that means 3 divisions below means what kind of error? If the main scale is above the circular scale, so it's a positive 0 error. First thing you should understand is it's a positive 0 error, right? So then the readings of the main scale and the circular scale for the thin sheet. So the main scale reading MSR is given, so which is 5.5 mm, and then circular scale reading CSR is also given, so which is equals to 48 mm, right? 48 circular scale for a, so this is CSR is 48. Okay, fine. So respectively, so the thickness of this sheet is, so first can you calculate what is the observed reading? First can you calculate, so what is the observed reading? So I'll just stand aside, you guys calculate the observed reading. So the MSR plus, so the CSR, right? So simply calculate the MSR plus CSR. MSR plus CSR. See, this is not the complete CSR, this is CSD. So are the coinciding division, I guess. See here. So below the line. So the readings of the main scale and the circular scale for the thin sheet. So this is which division is coinciding, that's what they are saying. Okay. So the observed reading will be MSR plus CSR. So the MSR value is 5.5 mm plus, so in place of the CSR, the least count into the coinciding division. So the coinciding division. So what is the 5? This is 5.5 mm. So the least count is 0.05, 0.005 into, so this is 48. So this is 48, right? Yeah, 48. So 48 means 240. So which is 5.5 mm. So this is, so 48 into 0.005. So which is nothing but 0.240. So which is nothing but, so we got, so 5.740 mm. So this is the observed reading. So but what we have to find, so the thickness, the actual reading, because there is a error. So how do you calculate the error? So there will be positive 0 error. There is the positive 0 error. So the positive 0 error, which is equals to least count into, so the coinciding division of circular scale with the baseline. Coinciding division of circular scale with baseline of the main scale. So now, so what is the least count? 0.005 into, so what's the coinciding division of circular scale with the baseline? So it is 3 divisions below, they said. So that's why the third one is coinciding. So which is nothing but 0.0015. No. 0.015 mm. So then you just calculate the final reading. The correct reading will be equals to the observed reading minus the positive 0 error, or simply write 0 error. Right, 0 error. So just do this calculation, guys. Just do this calculation fast. Do the calculation fast. Done. So directly you can calculate, right? So 5.740 minus 0.015. So which is nothing but, where we get the closest one is, so 5.725. 5.725. So mm. So the correct option B. Done? Chalo, next. So let's move further. So the last question for the today's session, try it on your own, guys. So what's the question says? A student measured the diameter of the small steel ball using the screw gauge of least count directly mentioned. The least count is 0.001 centimeter. So the main scale reading is 5 mm. So the MSR is given as 5 mm. And then, so the 0 of the circular scale division coincides with 25 divisions above the reference level. See here. So the which division? The some nth division, 25th division of CSR circular scale coincides with baseline of main scale. With the baseline of main scale. So just let it be. Next. So now if the screw gauge has a error, so the zero error is given. So the zero error is given as minus 0.004 centimeters. So fine. So the correct diameter of the reading. So first to find the observed reading. The observed reading is equals to, so we can calculate it as MSR plus the CSR. So what is MSR? MSR given as 5 mm. 5 mm, right? So plus, so this CSR. So CSR, how do we calculate CSR? So LC into the coinciding division. LC into the coinciding division. So here 5 mm plus, so LC, what is the least count? Least count is already given 0.001 centimeters into the coinciding division. What's the coinciding division? So 25th one, right? So from here you can get the observed reading. So you just do this calculation, guys. So once you get the observed reading, so the correct reading will be equals to, so what's the correct reading? The correct reading will be equals to, so the observed reading minus zero error. Zero error. So this zero error, take it with the sign. So you should just take it as minus 0.004 centimeters. So and one more thing, this is in mm, convert it to centimeters. This is in mm, so convert it to centimeters and then add it, because the least count is given in centimeters. So this value you will get it in centimeters. This whole thing you will get it in centimeters. So and then this is in mm. So convert this to centimeters. You get the observed reading in centimeters. So therefore observed reading minus of minus 0.004. So then you'll get the correct reading. So what you do is you just comment down the final answer. So just comment what's the final answer. Just you have to do the calculations. That's it. Clear, guys? So that's it. All about the screw gauge and vernier calipers. So chalo, we'll meet in the next session with the new chapter, that is basic maths, where in basic maths I am going to take 3 lectures where we'll cover all the basic maths that is required to cover the physics chapters. So chalo, till then keep studying, guys. All the very best. Bye. Take care.